Okay, so yesterday we talked about a chart, right? We came up with ratio, with fractions, with 6 different fractions. Remember, sine, cosine, tangent, cosecant, secant, and cotangent. Now, and then we had a little Greek letter called theta. It's a reminder how things looked like yesterday. There was a theta there. Now I don't see theta here, but I'm still going to ask you, find the value of each trigonometric ratio. Again, ratio is just the fancy word for fraction. Okay. Now, but here I'm asking for tangent of A. So theta, it's a corner A. That's where my theta is. We don't see it. I'm just going to call it tangent of A. I'm going to label my 3 sides. The big side is always called hypotenuse, so it's easy to label, H for hypotenuse. My theta is a corner A, so 24 is the opposite, 18 is the adjacent. Remember, opposite is far away, adjacent is close to. Now, we learned the ratios, right? You wrote those yesterday. So the ratio of tangent is opposite over adjacent. So in this case, 24 over 18. But 24 over 18, if I type that in my homework, is going to be considered wrong. I have to simplify my fractions. For simplifying, we divide each by 6. We learned that back in pre-algebra, right? We're geometry, so we should know how to simplify. Let me divide each of my numbers by 6. So my fraction is 4, right? 24 divided by 6 is 4. 18 divided by 6 is 3. 4 over 3. I cannot simplify anymore, so I'm going to type this as 4 over 3. I'm using the backslash for the over. Take a look at question number 8. Let me label my sides. The biggest side is hypotenuse. Some of you might be, how do you know that's the hypotenuse and not the 40? Because 41 is bigger than 40. All right, now cosine of C. I'm using the letter C. At this corner, that's where theta is. So that means 9 is the opposite, 40 is the adjacent. Now we learned cosine is adjacent over hypotenuse. So 40 over 41. Nothing else I can do to simplify them. So that's it, right? 40 over 41. Let me flip the page. Let me take a look at question number 9. My case is right here. Let me label the sides. 37 is the hypotenuse, because I said sine of A. Right here at A, that's where we're going to have the theta. So 35 is the opposite, 12 is the adjacent. Now we learned that sine is opposite over hypotenuse. So 35 over 37. Simplify if possible. In this case, I cannot. Take a look at number 10. 34 is the hypotenuse. The big side is hypotenuse. Now here, because I said cosine of Z, so I'm looking at the corner Z, that's where theta will go. 16 is the opposite, 30 is the adjacent. And we learn that cosine is adjacent over hypotenuse. So 30 over 34. Now simplify if possible. You see 30 and 34, I can divide each by 2. So it's going to give me 15 over 17. I divided each number by 2. I made my number smaller. So 30 over 34 is incorrect. 15 over 17 is correct. Okay, 2 more examples. Let's take a look at number 11. Let me label my sides. 50 is the hypotenuse to begin with. Sine of Z. So here at the corner Z, that's where my theta will go. 14 is the opposite. 48 is the adjacent. Remember, opposite is far away. Adjacent is close to. Sine is opposite over hypotenuse. So 14 over 50. Divide and simplify if possible. Let me divide each number by 2. So I'm going to divide by 2. So that gives me 7 over 25. Lastly, let's take a look at number 12. 17 is the hypotenuse, tangent of C. So let me mark my corner C. 8 is the opposite, 15 is the adjacent. Now tangent, I remember tangent is opposite over adjacent. So 8 over 15. Simplify if possible. This one I cannot. So 8 over 15. There you go.